Hello, welcome to this Vib Tip session. Today, we are going to talk about the use of sleep tables and the importance of its overturning moment resistant capability. A sleep table is required when we must perform a vibration test in three mutually perpendicular axes sequentially, but we cannot rotate the device under test and must remain in its functioning position during the test. This is a schematic of three-axis testing when we can rotate the device under test. And this when we cannot rotate the device under test and the use of a sleep table is required. A sleep table is a guided aluminum or magnesium plate connected to the shaker armature through a specially designed fixture called driver bar. To avoid stress to the armature guidance system, alignment between armature and sleep table is a critical issue. It's highly recommendable that both shaker and sleep table are supported on a common structure. The overturning moments, pitch, roll, and yaw resistance of the sleep table guidance system is an important feature and fundamental to define the most suitable sleep table design. To illustrate the effect of this overturning moment, let's consider a basic specimen fixed to the table. We will use a cubic structure with masses concentrated at its corners. The four blue corners are fixed to the sleep table and move in conjunction with it, while the red masses are joined to the blue ones by connector. Initially, let's imagine that we are exciting in frequency where there is no resonance of the structure. The upper level masses will have a longer movement due to inertia, and therefore will generate a pitch moment on the sleep table that should be absorbed by the sleep table guidance system to free the armature guidance system of this task. Now, let's complicate a bit the scenario. One side of the DUT, represented by the green masses, is showing a longitudinal resonance that causes an unbalance in the structure, forcing the green masses to move down and to the center. This movement generates both roll and yaw overturning moments that, again, should be absorbed by the sleep table guidance system. The taller and the wider the DUT is, and the higher Q factor of the resonance is, will determine the magnitude of these moments. In the market, there are different guidance system technical solutions, but basically there are four main types. First, table on oil film with a basic guidance performed in the central axis. Second, different type of journal bearings with or without synthetic granite base and on a low pressure oil film. Third, high performance hydrostatic bearings either standalone or distributed in a common block with high pressure oil film uniformly supporting the table. Fourth, T-film hydrostatic bearings distribute under all or most of the sleep table extension. Below you can find a table with overturning moments resistant for the four previous types taken for published brochures of the different manufacturers. We can see that pitch and roll moments figures increase by a factor between 2 and 4 as we increase the complexity of the solution, while the yaw moment resistance is clearly smaller. Anyway, it's important to consider that there isn't a universal procedure to calculate overturning moments for sleep tables, so these figures must be taken as references only. Summarizing, every overturning moment that is not absorbed by the sleep table guidance system is directly transmitted to the armature guidance system with the consequent risk for the vibration system. On the other hand, the most suitable technical solution is not necessarily the one with the highest resistance and probably the most expensive. It depends on the particular application, and spending time on this kind of analysis is well worth it. Well, thanks for attending, and let's meet in the next Vib Tip session.